Today we are doing section 5.3. We are going to use the vertex form of a quadratic function. So we are still dealing with quadratics, still dealing with parabolas. We are just going to discuss them in a different form called vertex form. All right, here is vertex form of a quadratic function. Y equals a times the quantity x minus h squared plus k. I would have that in your notes. The vertex is at the point h comma k from this form. And the axis of symmetry is at the line x equals h. So normally when we write this, a, h, and k will be numbers. X and y will stay x and y, but a, h, and k will be numbers. Kind of like when we had ax squared plus by plus c, and a, b, and c were numbers. It's the same kind of thing here. All right. All right, on example 1, we are asked to graph y equals negative 1/2 times the quantity x minus 2 squared plus 3. We are asked to identify the vertex, the axis, and 2 additional points. All right, so let's start with the vertex. From our notes above, our vertex is at what point? Jacob? Negative 2 comma what?
Oh, I thought you said negative 2 comma.
Okay, so you are very close to being correct. But if we look closely at that vertex form, it was y equals a times x minus h squared plus k, right? And our vertex was at h comma k, right? That's all in our notes right above this example. So when we are asked to identify h, we don't include that minus sign. That minus sign is just part of the general form. So we're going to switch the sign. So we think of that as being a negative 2, but when we pull out h, it's actually a positive 2. That's the tricky part. So 2, comma, and then k keeps whatever sign it looks like it has. So in this case, it's a positive 3. So be careful when you're identifying h.
So if that was a positive, 2 is not a negative, it wouldn't be the negative in the...
Yes, so if it were to be written as a plus 2 here, then h would be a negative 2 here.
Oh, okay.
It's like the opposite sign for h, but it uses the same sign that it already has for k. I know, it's a little tricky. We just got to keep it straight.
All right, so same with k, right? Like if it was a negative 3, it would come, well, stay negative, never mind.
Yep, k keeps its sign. All right, the axis of symmetry is at x equals 2. X equals h is our general form. We already identified h to be 2. And it's the same thing when we were graphing these before. Your axis and the x-coordinate of your vertex are the same number every time. That doesn't change just because we're in a different form. Yes?
So does this open down?
Oh, why do you think that? We got a negative out in front. That's still true. It's still going to open down because we've got a negative coefficient out in front. A is negative. So that's also still true from graphing these. If a is positive, it opens up. If a is negative, it opens down. All right, we are asked for 2 additional points. The first point they want to know is if x is equal to 0, what does y come out to be? So they're telling us they want that to be one of our points. So x equals 0. Y equals -1/2. What is 0 minus 2?
0.
No. -2 squared plus 3. What's -2 squared?
4.
A positive 4. What is -1/2 times 4?
-2.
-2. What is -2 plus 3?
+1.
+1. So when x equals 0, y equals 1.
Where is it at?
So before we identify our last additional point, we're going to graph what we already know. To graph 2/3, we are going to go right 2, up 3, put a point. We know our axis of symmetry is the vertical line that goes through our vertex, so we can go ahead and dash that in. All right, we know one of our other points is going to be at 0, 1. Zero, comma, 1 on our y-axis. How are we going to come up with another point, Charles?
Line of symmetry.
We're going to count how far away this point is from our axis of symmetry. How many spaces is it? 2. So we're going to go 2 more spaces so that we can get the reflection of it. And then we have to identify the coordinates of that point. 4, 1. Sounds good to me. And then last but not least, we sketch in our U. Ooh, that's not good. That's a little better. And like we said earlier, it opens down because the A, that number in front that was being multiplied, is negative. All right, I'm on example 2. I'm hoping that you have already been able to identify your vertex. Can anyone raise their hand and tell me? Cydia.
-1, -4.
Wonderful. Remember that when we pull out H and K, our formula has a minus sign built in, so we have to switch this sign. So if it looks like it's positive, it becomes negative. For our K in the back, it keeps its sign. So it was a -4, it's a -4. We got to be able to keep those straight. Can anyone raise their hand and tell me where my axis is? IN. The whole thing.
What? Yeah, he was getting.
What is IN
X
missing?
equals -1.
X equals -1. Very good. Remember?
The whole thing. I think you got it.
Nope, the whole thing means we've got to include the X equals on it.
I know, I missed the whole one.
Then we need to find additional points. So they are reminding us on the slides again that they want us to plug in X equals 0 to get our first point. If I do that, we have Y equals 2 times 0 plus 1 squared minus 4. What is 0 plus 1?
1.
What is 1 squared?
1.
What's 1 times 2?
2.
What's 2 minus 4?
-4. -2.
-2. So when x equals 0, y comes out to be -2.
This is exactly like that. Oh, you get aggravated when you get back grades?
On example 2, we need to graph. So let's start with our vertex. -1, -4 means we go left 1, down 4. Put a point. All right, let's sketch in the axis of symmetry. It's going to be a vertical line going through our vertex. And then over here we found one additional point, 0, -2. So we can plot that. Jacob, how can I get another point?
You move 1 to the left.
To the left of?
The line of symmetry.
Good, the axis of symmetry or line of symmetry. So we reflect this point over our axis of symmetry to get another point. Then we need to identify that point. What is it?
-2, -2.
-2, -2. And we form our U as best we can. All right, on example 3, we are asked to write the equation using this parabola. We're acting like this parabola was already provided to us. And we want it to be in vertex form, meaning y equals a times x minus h squared plus k. The easy part to identify should be h and k. Where do we find h and k? At the vertex. What does our vertex appear to be on this problem?
4, 3.
3, 4. This point up here looks like our vertex. So we can go ahead and fill that in. Y equals a times x minus 3 squared plus 4. But now what's the other variable here that we need to turn into a number? A. We have not talked about a way to find A. So in order to do this, we are going to have to use one of the points that we have. We are going to have to plug in x and y and solve for A. Okay, so once you plug in h and k, we have to plug in x and y to solve for A. If you need to write yourself a little note, that might be a good idea. 5, -4. So what does that mean I'm plugging in for y? -4. -4 equals A. That's what we're going to be solving for. Then what are we plugging in for x? 5. 5 minus 3 squared plus 4. Now let's start simplifying the right side.
It's 4.
-4 equals A times, what is 5 minus 3? 2, but then we square it, we get 4 plus 4. What's going on between the A and this 4? Multiply. We're multiplying those. And we're adding a 4 on the end. What should we undo first? We need to subtract in order to undo the addition first. So if you want, you can rewrite this as -4 equals 4a plus 4, if that makes it easier to see what you need to do. It's the same thing. A times 4, 4 times a. So if you want to rewrite it, go ahead. All right, so we subtract 4 from both sides. What is -4 minus 4? -8 equals 4a. So then we have to divide, and we get a equals -2. Why does it make sense that a is negative?
Because 8 is negative, you divide it positive, so it comes out to negative.
Why else, Lanaya?
Because the parabola goes down.
The parabola opens down. So if you start off with the picture, I just drew all over it. If you start off with the picture and you get an A that is then positive, you should probably be thinking, I did something wrong somewhere. But we're not done yet. We still have to write our final answer. To write our final answer, we're going to rewrite it, plugging in A, H, and K. So y equals -2 times x minus 3 squared plus 4.
That means you don't take the right one, you have to do it again.
No, you can use any of the points.
Oh.
If we had used any of these 3 points, we should have come up with -2 for A.
Oh.
Okay. So we've got these points plotted. That makes this parabola here that we see. So we need to write an equation in vertex form. So just to remind ourselves, that is y equals a times x minus h squared plus k. What can we plug in right away? H and k, because we find that from our vertex. What is our vertex? -1, 0. So that point was my vertex. I'll label it up here, or you can label it on your graph. So when I plug that in, that gives me y equals a times x plus 1. Very good. We were subtracting, and this h is negative. Subtracting a negative means that we are really adding 1. And then what about k? It's 0. Do I need to write plus 0? Do I need to? No. If you want to, you can, but you usually will not see it written there. So you'll have to know when you're doing these, if you see a problem where they don't put plus k or minus some number back here, that k is 0. What are we still going to need to find? A. So we need to plug in a point. Which point would you like to use? Sure. What's going in for y if we use -2, 2? 2. 2 equals, we don't know a. What's going in for x? -2 plus 1 squared. What is -2 plus 1? -1. Remember, only what was in parentheses gets squared. So what is -1 squared?
1.
What's a times 1?
A or A1.
Just a or 1a. So a comes out to equal 2. Why does it make sense that a is positive? Our parabola is opening up, so it makes sense to us that a should come out to be positive. But are we finished?
No.
Our last step is to write the equation. We actually have to plug in all this stuff that we figured out. Y equals 2 times x plus 1 squared. And then if you want to put the plus 0, you can, but you don't have to. And that's it. Once we figure out what h, k, and a are, we just plug them all in. Questions? All right, on our next example, we are going to convert this from standard form into vertex form. It's going to be easiest if we just use this to identify our vertex. Okay, so I wouldn't necessarily try to just start rearranging this. I would find your vertex. You can always get to vertex form if you have a vertex. How do we find our vertex from standard form? What do we always start with? We identify A, B, and C. What are my A, B, and C?
2.
A is 2.
B is 10. C is 7. B is 0.
Once we have our A, B, and C, what did we do to get our vertex?
Y, x equals -b over 2 times a.
Very good. X equals -b over 2a. What's the opposite of b? -10 over 2 times 2. What's 2 times 2?
4.
Will this reduce?
Yeah.
Yes, it will.
-2.
-5/2, or we can write it as -2.5. All right, then, that's not our whole vertex, that's just the x. How did we find the y part of it?
Plug that back in.
Plug it back in. So y equals 2 times negative 2.5 squared plus 10 times negative 2.5 plus 7. Now, I am confident that you can all use a calculator to figure this out, but for the sake of time, I'm going to tell you that this ends up being a negative 5.5. Then we just have to go to our vertex form. Y equals a times x minus h squared plus k. What's a?
2.
2. We can use the same a. That's what's nice about this. 2 times x. Instead of putting minus h, since h is negative, I'll put plus 2.5 squared. And then because k is negative, I would put what?
Negative.
Negative or minus 5.5.